Who, me? Yeah. I have tons of cash. I don't even care. That's on the video now. I'd buy everybody banana bread. All right, so 18.2, day number 1. I'm going to review what we did yesterday in 18.1, day 1, which is we took a Cartesian equation like y equals something times x, blah, 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 and we're given these parametrics now, where t is a controlling variable. Why would we do that? Because sometimes things in life aren't functions, right? So we have to split it up so that we can write a function in terms of t that gives us x, our horizontal movement, and the same thing for y, our vertical movement. And then we get these parameters on t. Right? So our parameters on t, our t is greater than or equal to -2. Okay, so what I'd do right away if I were you is I would create this taxi table right over here. I call it the taxi table. And I just start plugging in values for t. And I typically go in integer steps. Keep it simple that way. And then what I do is I plug those values into x for t. So if I plug in a -2, I square it, I get 4. I subtract 3, I get 1. I plug in a -1, I square it, I get 1. I subtract 3, I get -2. I plug in a 0, square it, I get 0. I subtract 3, I get -3. Yes, I'm taking each of these values for t. And I'm plugging them in right here consecutively. And they're giving me different values for x. All right, so they're giving me these values for x, which are going to give me half of the coordinate pairs that I'll get for the points on our graph. Okay, so if I plug in a 1, I get -2. You see the symmetry taking place? And I plug in a 2, I get a 1. I plug in 3, I get a 6. I plug in 4, and I get 13. Okay, so I've got the x values for the points on this parametric equation. Now I do the same thing for the y's. It's always nice when you get a linear function for your one of your two, either your x representation or y representation, because it's linear in nature, so it'll always change by the slope that you see. So my y value, my first y value, if I plug in a -2, would be -5. Now this +2 tells me that as t changes by 1, y will increase by 2. It's like slope. So I would get a -3, then I'd get a -1, then I'd get a +1, 3, 5, and 7. Okay, so now we plot these. These are just coordinate pairs. So we started here at t equals -2. That starts us at 1. Okay, so I go over 1 to the right and up 5. Boom. Down 5. That's what negative means. Oh, good job, Mr. Ludd. Over 1, down 5. There we go. Then I go left 2, down 3. And then left 3, down 1. And then left 2, up 1. And right 1, up 3. Right 6, up 5. And I'm going to kind of run out of space here. But if this was where t equaled -2, that's where we're going to start our parametric. And then we're going to connect the points. Of course, that would go on forever. Now, the orientation of this parametric equation is this way. This is necessary so we know the direction of the parametric. Where is it going? What would the domain be for x? My x value, my furthest x value to the left, what is it? -3. Is there any limit on the right side? No. So that would be the domain of x. Okay. Now you might be asking, well, how would you come up with a Cartesian equation of this? Because it's not a function. That means that it'd have multiple pieces that have a positive stem and a negative stem, probably a square root of some sort, right? So what we did yesterday on this was we took this and we solved for t. Would you agree that this would be true? Just add 3 to both sides, yeah? Okay, and then I take the square root. Do you agree that's true? Yeah? Okay. So if I want things in terms of just y and x, that means I want to eliminate t. So what am I going to plug in right there? What I got for t originally in red there. So I'm going to plug in plus or minus square root of x plus 3. Let's simplify that, and then let's look at it. Hey now, check this out. That is a square root that's been shifted how many units to the left? 3 units to the left. And then how many units down? 1. What's this point? Oh, it's been shifted to the left negative, or to the left 3 and down 1. Okay, that should be a negative 1, by the way. Okay, where does the, now there's 2 stems to this. Where's the purple one? This upper portion. Where's the yellow one? This lower portion, right? Now the restriction on t then will stop the graph right there. That's a parametric. That's our Cartesian form of that parametric right there. Boom shock. But pretty much that was all of yesterday's lesson. Let's go here for a moment. We did this yesterday, but if I took both of these items and I squared them, I think we can all agree that we'd get x squared equals cosine squared t, and y squared equals sine squared t. Now, if I want to get things in terms of just x and y, there's a nice little trick to this. I'm going to add this and this. X squared plus y squared. And what is sine squared plus cosine squared? 1. So that's a circle with radius 1. Sick. Now, you might be saying, well, that's not in terms of y, right? And you're like, well, I get it. That's 1. I get that that's negative 1. This is positive 1. And this is negative 1. I get it. Like, I see, right? And directionally, we don't have parameters right now, so it doesn't really matter. But you might be saying, well, what the heck? Like, that's not y in terms of x. Okay, fine. You want to be like that? Okay, there you go. All right, there's your equations. It's not a function, but I can write it in 2 stems, where the positive stem is up here, and the negative stem is down here. So there's your 2 equations. 1 minus x squared. Boom. Yeah. Love it. What would the domain here be for x? Yeah, negative 1 to 1, right? There's our domain for x. Cool. All right. We're going to use this as a review for a little bit later. Today's lesson. Last hour of today's lesson took me 4.5 minutes total. What? Sick. That's like awesomeness. It's going to be great. Okay, so here's kind of the opposite of what we did yesterday. We're going to take this Cartesian equation and we're going to put it into parametric form. Okay, now this is really crazy, but it means I have to set something equal to t. Typically, you're going to take x, and you can set it equal to t. So if I set x equal to t right here, right, there's the first part of my parametric equation. Then what is y going to equal? T squared. And you wrote your parametric equations. What? That's too easy. Well, you're not done yet. You need parameters on t. What would the parameters on t equal? Yeah, negative 3 to 2 because t and x are the same. Will t and x always be the same? No, not all the time. But in that case, they're nice and easy.
So we're just replacing t with x.
Correct. So you can call, like it works here because this is a function, right? It's not always the case, right? This is a function. Would you agree? It's going to pass the vertical line test. So I take my independent variable and I set it equal to t. So here I got x equals t again. So then y would equal t to the 5th plus 2t plus 1. It almost feels like cheating, doesn't it? Like, that's too easy. It's the foundation that's important. Of course, here t is going to be greater than or equal to negative 1, less than or equal to 1.4. There you go. Now, the next piece here is a little bit interesting, but I'm going to have a line segment connecting those 2 points, right? So this is the requirement here. It's got to be a line segment in order to use this method. But would you agree that, let's say t equals 0 right here. When t equals 0, x equals 2, right? When t equals 0, x equals 2. How about if we take one step, right? And we just say, let's say t equals 1 there. How far did x travel? Well, it went from 2 to what? To 1. So what was its change? 1 which direction? Negative, right? So this is how we would write our parametric here. It would be x starts at 2, and then it takes a step down, or to the left in this case, negative 1. Right? It's changed by negative 1. How would we write the parametric for y? Starts at negative 3, and then what? Yeah, it goes up 8. There's our parametric. Okay, what would be the parameters? Now that we know that t was between 0 and 1, what would x be between for our domain? What are our two values for x? 1 and 2, right? That's our domain. That's the domain of that directed line segment. It's almost so easy that you can overcomplicate it. Okay. So let's look at, I think I want to look at some homework because that's it. That's the lesson. That's done. Let's look at a piece right here like this. The directed line segment from 3, negative 5 to negative 2, 2. What would we say for x? Where does x start? 3. How does it change? It goes down 5. Done. Right, there's my parametric for x. My parametric for y starts at negative 5 and goes up 7. What are my what's my domain? Yeah, negative 2 to 3. Now in an easy line segment, what would the range here be, just out of curiosity? What are my y values? Yeah, negative 5 to 2. Boom. Now if it's quadratic, it might not be that simple, right? Because a line segment, you know, will be between those two values at all points, right? But a quadratic could go down below, find a local minimum, and then come back up. So the range is pretty easy there for that. Okay, let's do number 29 because it's, well, let's do 27 as well. I don't care. I'd rather just, you know what's going on. Okay, so what do we want x to be here? T. Yeah, it's the independent variable. What would y equal? 4 minus t squared. Beautiful. What are the parameters on t? Yeah, they got to be the same as they are on x, right? Because t and x are equal. All right, so let's say you're not quite sure what to do, and you're like, you know what I'm going to do? I'm going to set y equal to t. I'm going to set y equal to t. Okay, well, that's fine. But then what you do to yourself is you do this. You create more work to solve for x. Because we want this as x equals something, y equals something. So basically what you've done is you've said, okay, well, I'm going to have to do this. And then that'll make that this. How many people want to do this? Not it. Right? So x equals plus or minus the square root of 4 minus t. Like this set of parametric equations right here with parameters from, it looks like 0 to 0, right? Because now t equals y. So the parameters on this would be t goes from 0 to 0, which is kind of weird. But basically what you'd get is you would end up getting the same plot as the other. You just took a whole lot more work to get there. It's great. Love it. Okay, so let's look at 29. Which is the independent variable here? Y is technically, it's organized as the independent variable. So what I would say is I would say that y equals t in this case, which would make x equal to t squared minus 9. Do I have any simplifying to do there? No, none. It's finished, right? But with the parameters on t, now it's going to follow the y values, right? Correct, -2 to 3.
So if we're
Yeah, what I would do is if you have x isolated all by itself like this, use the other one. Right here I have y isolated all by itself, so I set x equal to t. Down here with x isolated, I set y equal to t. It'll make the arithmetic that much easier. And that's 18.2, day number 1 in the books. $19.25 to GNC, to the 100th sub. It's just increasing by the day. I can't accentuate how much importance there is on protein and gains. Enjoy your day, people on the web.